I want us to discuss about the electronic product design process itself. Thank you, Peter. So I want to keep today's lecture very brief, because it's basically an overview of what now we'll be doing in each and every design in order for us to come up with the products that we do desire to design and of course push to the market. So I'm talking of the process that we do follow in order to design such products. As you can see, these are just sample PCB work that we've done here in our lab. Yeah, how do you do the layout? How do you select the components? Well, we've known what components exist, and as you can see from these images, there is no other new component. These are all the components that we've been talking about. So the entire process of electronic product design follows this particular order. So like we do have ideation being the first process. This is where you come up with the idea and checking about the viability, and then starting with the execution. We go to component selection. That's once you have a solid idea, go to component selection. What am I going to use for this design? After there, you can do the concept and design flow diagrams. Then at that point, you also select the EDA tools you're going to use. You do schematics. This is also the point where you draw symbols, footprints, and perform some ERC. You do some PCB layout as well. Routing also comes in that stage. Then after there, you do the production files. Now these are the actual files that we do send to the fab houses. Then after there, once you have all the files, we go to fabrication. Well, after that, we have electrical tests, and that's when we receive our PCBs. And finally, we have a proof of concept being done, and we can push our prototype to production, now getting the final product. So I'll start with ideation. Yeah, and what we should check, say, in each and every stage. It's just an overview of what they actually entail. This stage is where we do the formation of ideas or the concept. It's the stage where you check the viability of an idea, and you should have a deep understanding of this particular stage. That is before moving on to the next project. And of course, ideas do come from two sources. One, it could be your own idea, and also it could be a client's idea based on a client's project, that is. So as a designer, generally just seek to understand the client's idea so much. Do punch your clients with relevant questions so that you may not run into problems such as charging the guys and delivering some substandard work. So if it's your idea, just criticize it, talk to some of your colleagues or your guys, and just check online on some literature review and stuff like that. Then if you're happy with your idea, just move forward and go to the next step, which is the component selection step. But before the component selection, you should now be thinking about, even as I select my components, how do I get the flow diagram? Like, how do I visualize the whole thing now coming up all together? Let me pull something here so I can show you what I mean. For instance, this is a flow diagram for a charging circuit. It was for a charger, for a portable charger actually. Say one like the ones that are used by Apple's AirPods. So you see we have the power input, you visualize everything, what happens there. It's that we do charging and protection. Yeah, then the battery and the stuff interacts with everything here. We do some DC to DC circuit there. We sense the 5 voltage output power. Then we have our MCU here. What is it doing? It's measuring and monitoring voltages with some of the voltage dividers we did talk about. It also senses the removal and plugging. So the output is now being sensed by the MCU. We talked about the microcontroller units. Then we have our outputs here, the feedbacks, that the LEDs could be tricolored or bicolored. Now, this is basically the entire concept in terms of how am I visualizing this idea to fall into place, say, once you start now putting pen to paper. So this is always good to draft something like this, gives you an idea, and also when you are designing, serves as a blueprint. You can keep on referring and moving forward with it. It's now from that stage now where you perform a component selection here. So there are factors that we do consider. Of course, pointers as the issue here, that they should be very good and small parts. And we talk about there being a caveat there. We'll see what that entails later. That you should also get your parts from reputable companies or reputable suppliers. For example, I talk of Texas Instruments here, TI. So what are the important things to do here? When you're at this stage, you should read and understand datasheets so much. I did talk about datasheets, and I'll keep on talking about datasheets throughout the course, throughout the program. They're very important. Then you do compare the aspects, or rather the specs of different candidates. Say you want to select this IC over this IC, do have a list of specs, what outweighs the other one, and then you can go with one that has like the best parameters, say in terms of voltage limits, what's the package, what's the current here, what are the temperature capabilities, is this one better? Yeah. Check also in terms of packages, do I need something big, do I need THT, do I need SMT, and stuff like those. And so those are just the aspects that you consider when it comes to component selection. And once you are happy with all the properties that you need when it comes to a component that you select, then you're good to go to proceed to the next point, because you have everything. Now you have to dive into the EDA tools now.